Okay, I think we can start. Hi everybody, for this new talk of our PhD seminars, let me introduce you Davide Caputo, which is a second year PhD student. Today he's gonna talk about this vulnerability that takes into account this hybrid application. So I let him explain whatever it is.
Thank you. Good afternoon, everyone. Today, I will present Droids in Disarray, detecting frame confusion and hybrid Android application. So, in this seminar, I explain what is frame confusion. I propose a methodology to detect frame confusion in an automatic way that is based on static and dynamic analysis. Implement this methodology in a prototype called FCDroid, and shows the result that we have obtained after analyzing 50,000 of applications taken from Google Play Store. So, today, the landscape for mobile operating system is mostly divided between Android and iOS. So, each mobile operating system has its own SDK and developer language. So, for a company that would like to reach the largest number of users, should implement the same application for all mobile operating systems. Exit 3 solutions for development application, native, web, and hybrid solution. Of course, each solution has pros and cons. For example, native application, sorry, but I am. Native application offer best performance. The application can access all operating system API, offer, of course, best user experience, but at the same time, if you develop an application for Android, you cannot use the source code also for iOS application. And for a company that would like to develop an application for both mobile operating system, should involve several different developer groups, one for Android and one for iOS, and is an expensive task. The counterpart of a native application are web app. Web app are developed using standard web technology like HTML5 and JavaScript, and they are executed in a web browser like Chrome. So, can be executed on every smartphone independently from the underlying mobile operating system. So you can develop a single application that can be executed on every platform. So reducing the cost, but an application has a limited access to operating system API, usually only API that are supported by HTML5, like GPS, for example. Of course, doesn't work offline and have limited performance because the application is executed inside our browser. To overcome such limitations, I've been proposed hybrid application. Hybrid application allows the portability on all platforms, have better performance with respect to the web application. The hybrid application can access to all operating system API like file system, SMS, network, or whatever you want, and works offline. So, an hybrid application is composed by 3 main components. The web app is the place where the code resides. An hybrid application is implemented as a web page, so using standard web technology. A web view component, that is a mobile component that embeds a minor browser with limited feature, and the native application, the native code, because an hybrid application is a mix of web code and also native code, for example, in Android Java, if used. The web view, moreover, create allow and ad hoc interfaces that create a communication between the JavaScript code inside the web application and the native code, for example, Java, So a JavaScript method can invoke a Java method inside a native application, and also a Java method can invoke a JavaScript method through this interface. So a developer needs to bind a set of Java methods to this interface. So you cannot invoke every method, but only a specific method that developer bind to these interfaces. This mechanism is handled by the web view in a synchronous way. So, for example, if you have some method in a web application, in a web app, that invoke some native method, the web application doesn't wait a result. So after the result is ready, the native app invokes some callback, JavaScript callback, passing the result back to the web page. This is why? Because don't stop the user interface, because for offer best user experience. So if you have an application and the user interface is blocked every time, I remove the application. So hybrid application, of course, from a security standpoint pose several challenges. First, because merge two worlds, mobile world and the web world. For instance, a well-known attack in the web world, cross-site splitting, become more powerful because the surface attack is broader respect to the web app, because you can use different channels, different sites, for example, Bluetooth, Wi-Fi, camera, to attack the application. Moreover, the code, the JavaScript code, can use the platform-specific feature like GPS, file system, SMS. But also, hybrid application can create new vulnerabilities that doesn't exist neither in the web world and mobile world, like frame confusion. But what is frame confusion? So this is simple hybrid application respect to previous. Here we have native app and web view component. Here we have a generic web page. So on a generic web page, from now we call mainframe, and inside this could be contain an element that is widely used in the web, called iframe. Iframe usually is used for incorporate advertisement that come from different domain respect to the mainframe. In the web world, if this page is located in different domain, cannot communicate with each other. But in hybrid application, thanks to a vulnerability that called frame confusion, create this malicious interaction between the two pages located in different domains. This is why, so I said before that a developer can bind a set of methods to these interfaces, and this method is handled in a synchronous way. So the problem is that every iframe, every child frame inside this mainframe can invoke and access to these interfaces, and because is handled in a synchronous way, the result is forced back to the mainframe. So the frame confusion creates communication between child and mainframe. This communication between web and native world, handled by the web view, handled by passing the same origin policy. The same origin policy is a policy in the web world that isolates the content of two pages located in different domains. The frame confusion can be exploited using a compromised child frame, like for example an advertisement, a malicious advertisement, or a compromised mainframe. In the first case, for example, an attacker can create a malicious advertisement campaign or a man-in-the-middle attack to the advertisement, can invoke some Java method through these interfaces. This method compute do stuff and send a result to the mainframe that is the legitimate page. For example, here an attacker can invoke a method to send an SMS or call some number, for example. On the other side, instead, we have a mainframe that is compromised by an attacker, for example, after a man-in-the-middle attack, and the legitimate page is inside the child frame. So, a legitimate page can invoke every method through these interfaces. For example, this interface could retrieve some sensitive data from databases, but these data are sent to the mainframe that is under controlled by the attacker. So, how occur frame confusion? Frame confusion occurs when the app requires the internet permission, of course. If the app uses at least web view that enable execution of a JavaScript code, because to default JavaScript code is disabled. The web view set at least one JavaScript interface. These interfaces expose at least one public Java method, of course, and the web view loads at least one web page with at least one, of course, one or more iframe element in the case of attacker by compromised child frame. And the web page does not enforce any mitigation technique like content security policy or sandbox attribute. These techniques usually are used to isolate the iframe and disable the execution of JavaScript code inside iframe element. So, we implement our methodology in this tool. That this tool is based on static and dynamic analysis. The first module, the static analysis module, decompile the application and analyze all the source code to locate all the API related to the web view component. In the dynamic analysis module, of course, the application is installed in a virtual testing environment and has been stimulated in an automatic way to monitor all network traffic and all API invoked by the application. The website dumper that collects some information from static analysis module and dynamic analysis module and download all the web page that the application loads inside the web view component. The exploitation tracker finds the situation that can be boost the exploitation of frame confusion, like the use of HTTP connection, for example, use of vulnerable JavaScript library, or some JavaScript code vulnerable, for example, to cross-site scripting. And the frame confusion detector that collects only this information and detects if an application is vulnerable or not to frame confusion. So, we show some results after analyzing 50,000 of applications. The first top 3 ranking application from Google Play Store, and FCDroid discovered that half of them are hybrid. So, hybrid I mean an application that uses at least one web view component inside it and enables the execution of JavaScript. And 6.63% of them are vulnerable to frame confusion. So, to show the impact of this application, we show that more than 250 million of installation are this application, and 60% of them use HTTP connection. So, I said before, FCDroid is based on static and dynamic analysis technique. So using only static analysis technique, we compare the result with using only technique, static analysis, or only static analysis technique, or only dynamic analysis technique with FCDroid. Using only static analysis, we discovered that about 12% of them are potential vulnerable. Potential because we analyze all the source code of an application, also the source code that maybe will be never executed inside the application. Using only dynamic analysis technique is not exhaustive because we analyze only the public surface of the application, because the dynamic analysis is computed in an automatic way. Instead, using a mixed approach, FCDroid discovered that 6.63% of them, of all applications, are vulnerable. So, increase the detection rate of dynamic analysis of about 2%, and validate more than half of potential vulnerable applications detected by the static analysis. So the remainder should inspect manually to validate if an application is vulnerable or not. I said before, exists some mitigation technique to isolate the iframe element, but for all applications that load at least one web page and iframe element, only 31% of them use content security policy, and no one uses sandbox attribute. That is an interesting result. So now I show you a real exploitation of frame confusion, a real application. This is a Korean news application with more than 1 million of installation. This application uses HTTP connection and expose several interfaces. Oh, sorry. Okay. An attacker in this case, we are able to compromise a child frame using a man-in-the-middle attack. So, the application requires original advertisement. The attacker forwards the original request to the server, but blocks the response to the server, injecting a malicious advertisement, like this. This is an example. In reality, the advertisement that we are able to compromise is not show you, is inside the application. So, we using some interface that the application expose that are able to open any web page without any kind of sanitization. For example, we are able to open a fake login Twitter inside the application, inside the main frame of the application. So a user can read the news, at the same time open login Twitter. Maybe a user can think, okay, maybe I need to insert my username and password to read the complete news. Okay. So, we propose an hybrid methodology for detecting frame confusion that is really a problem for hybrid application. We developed a prototype that implements this methodology, FCDroid, and we analyzed 50,000 of applications taken from Google Play Store, and we found that 6.63% of them are vulnerable. So, if you want, you can try FCDroid. It's like a software service. You can upload an application, and after a couple of minutes, you get the result if an application is vulnerable to frame confusion or not. Okay, thank you.
So, any questions? Please, no? Okay, go.
Curiosity. Have you tried it on Apple Store?
Yes, so also a US application is vulnerable to frame confusion. I developed a prototype also for iOS but get the iOS application is more difficult with respect to Android. So I try to download a lot of applications to extend this work with also for iOS. But also iOS application is more vulnerable.
I think that on Apple Store, the applications are more verified in some way. It's different from Google Store, Google Play. So I think that it could be interesting to see the results.
Yes, if you want, I can show you my prototype for iOS. I developed it on GitHub on private repository, but it's more difficult to get iOS application.
So you showed the actual attack on the real application. It was an example of from child frame to the
So
Were you able to replicate the same thing, but on the contrary? So you control the mainframe and then try to, I don't know, steal some password accounts from child frame?
Yes, in this case, yes, because the application uses HTTP connection. So if you want, I can change mainframe with a page under your control. But in this case, yes.
So you can.
But I'm not trying.
But only because it's an HTTP. So it's an HTTP. I can because I have to modify the packets. So so there should be an individual attack for using such a.
Because if I compromise a mainframe, it's more difficult in reality because you need to have, in this case, compute a man in the middle attack.
Okay.
So instead, if you are going to compromise a child frame, other to a man in the middle attack, you can also create an advertisement malicious campaign.
Okay.
Maybe the developer incorporate your malicious advertisement in your application.
But by using the child, you can change the frame.
Yeah.
Okay.
Yeah. But it's situated in two different domains. So in reality, you cannot. So in the web world, you cannot communicate. So you can create a web page of somewhere and control, for example, Facebook page that is distributed.
But you can change also the theme in a page.
Yeah.
You can call Java functions.
Yes.
But go JavaScript functions that changes attributes. You can change the CSS.
Yeah. Because in this case, okay, the application exposes a several methods. Some of them from get information about application, and one of them is called live login, that you pass a generic URL to this method, and the application loads this URL without any kind of sanitization. So I use these interfaces to create my login page on a server.
So basically, it's a cross-site script. You apply cross-site script, so the advertiser sends you some JavaScript inside the URL, and then the application executes the URL. Wow. Any other questions? Go.
Excuse me, I'm not an expert of mobile development.
Okay.
I'm just curious about something. When I code an app on Android or iOS, and by the moment that I upload it on the Play Store, on the does Google or Apple make some sort of check if my app is either malicious or vulnerable to some attack?
No, only malicious.
Okay.
Only malicious. So if you upload the application on Google Play, for example, before the Google Play say, okay, you can publish the app on Play Store, analyze the application. But after the application is published, the developer can change.
Okay.
Can change the application without any problem.
Okay.
So you said something about you do dynamic analysis.
Yep.
Which kind of dynamic analysis? So you test.
Sorry, Lucas, please.
So which kind of dynamic analysis have you?
Okay.
So you test against
Is
some
there-
kind of specification.
Okay, so I started the application in a virtual environment using a software that called Droids stimulate dynamic weight application, and at the same time monitor the network traffic that the application is generating. And we use also a tool that's called Expose with a specific module that hook all API invocation. So I collect all this information.
Yeah, and how can you evaluate this data? So how can you say these data are vulnerable or not? So
Yeah, okay.
You have specification, you have something.
Yeah, I collect all the information about the web view. So for me, an application is vulnerable if a specific web view enables execution of JavaScript with an API invocation. If this web view also creates JavaScript interfaces, okay, this is also another API invocation, and the web view load some web page. Some web page I collect this information about network traffic. I collect all this information, and if the condition is respect, okay, enable execution JavaScript, okay, create these interfaces, okay, this web page contains one or more iframe header, for me it's vulnerable. And of course, doesn't include any mitigation technique.
Yes, but this condition is written in some kind of language, or you test it?
I think he's asking whether you do this by hand or whether it's an automatic.
In an automatic way. See, all this information okay, is collected by frame confusion detector. So dynamic analysis module collect network traffic and dynamic method invocation and send to frame confusion detector. Also for static analysis module that list of permission, static method invocation, collect all this information, also the information that go from exploitation checker and website dumper, and all this information satisfy the condition that I showed you before. Okay, the application is vulnerable. I tried some of applications that FCDroid detects as vulnerable and all is vulnerable. So I show you maybe for you the more interesting application because I can show you a real attack. So I changed the content of the mainframe.
Any other questions? Thank you again, speaker.